This video is going to run through both finding intercepts and graphing lines. Let's start by doing a couple of examples that involve graphing linear equations in two variables. And we're going to graph by making a table of values that contains at least 3 points. So I've got the equation y equals 2x minus 3. So I'm going to make a table of values in xy grid, and I can choose any 3 numbers I want for either x or y. Doesn't matter, I can pick any numbers I want. I think just for simplicity of arithmetic, I'm just going to choose x equals 0, 1, and 2. Then I can find the corresponding y values by just plugging those numbers in. When x is 0, I put that in for x. I get y equals 2 times 0 minus 3. So that's 0 minus 3 or minus 3. So 1 point on my line is 0, negative 3. I can do the same thing for x equal 1. I plug that into my equation. So put 1 in for x, and I get y equals 2 times 1 minus 3. That's 2 minus 3, or negative 1. So our next solution point is 1, negative 1. And then finally, I'll plug x equal 2 in. Y equals 2 times 2 minus 3, 4 minus 3, or 1. So we've got the point 2, 1. My next step is to plot these 3 points on my rectangular coordinate system. Because I'm graphing a linear equation, these 3 points should lie in a straight line. If they don't, it means I made a mistake somewhere, and I need to go back and recheck my work. So I plot at the point x is 0, y is negative 3. Then we've got x is 1, y is negative 1, so go down 1. And finally, x is 2, go up 1, y is 1. And I notice that these 3 points do lie in a straight line. So to finish, I'm going to connect the dots, and that line is actually going to be a graph of every single solution to this equation. Now, I like always having at least 3 points, then you can visually see if your points lie in a straight line. But if it helps, you can definitely plot more points. You can do as many points as you need to visualize this graph. But the main idea here is our linear equation, so the graph is always going to be a straight line. And so at a minimum, we really should be plotting 3 points so we can verify that we do have that straight line. All right, here's another example. I have the equation 3y minus x equals 6. I'm going to create a table of values, and I'm going to plot at least 3 points. I can pick any numbers I want for either x or y. And in this case, my equation isn't solved for one letter. So I think what I'm going to do is I'm going to pick 0 for x and then 0 for y. Zeros are pretty easy to do math with, so I usually like choosing those in my table, if possible. So we'll do 0 for x and then 0 for y. And then in a minute, I'll explain why I chose 3 for my third point. Okay, so I'm going to start with x is 0. I put 0 in for x, and I'm left with 3y equals 6. To solve for y, we have to divide by 3, and that gives me y equals 2. So we've got the point 0, 2. Then I'm going to take 0. This time I'm going to plug it in for y. So I put 0 in for y. 3 times 0 minus x is 6. That gives me minus x equals 6. Divide both sides by negative 1. So x is negative 6. Negative 6, 0. Finally, I need to pick any other number for either x or y. And so in this problem, I did notice that when I was solving for y, notice that I divided by 3. And so choosing something that's a multiple of 3 might be a good idea. It might help me avoid fractions. Fractions aren't bad, but the math and the plotting is a little bit easier if you can manipulate the numbers and get whole numbers. So again, I'm just noticing that, okay, when I solved for y, I had to divide by 3. So what if I choose 3 for x? Let's see what happens. I plug 3 in for x, so now I've got 3y minus 3 equals 6. To solve for y, we're going to add 3 to both sides. So 3y equals 9. Finally, divide both sides by 3. 9 divided by 3 is 3, so y is 3. And there's my third point. Finally, the last step is plot these 3 points in our rectangular coordinate system. These points should lie in a straight line. If they don't, that indicates that we probably made a mistake somewhere and we have to redo our math. So 0, 2. X is 0, y is 2. And then we've got negative 6, 0. X is negative 6, y is 0. And then finally, x is 3, so over 3, up 3. And these points do appear to lie in a straight line, so to finish, I'm going to connect the dots. And this line is the graph of 3y minus x equals 6. Again, every single point that lies on this line is another solution to this equation. All right, here's one more. We've got the equation x equal 2. This is kind of a special case because notice that this equation doesn't have any y's in it. It only has the variable x. And so when you make your table of values, what that means is the x values are always going to be 2. So everywhere. And so when you fill out your table, you can just automatically put 2's in for the x's. That's what this equation is telling us. X is always 2. And then you can pick any random number you want for y. I just did 1, 2, 3. But I can pick any number I want for y, and the x's are always equal to 2. So this is kind of a special case. And let's see what this looks like when we graph it in our coordinate system. So the first point was 2, 1. And then we've got x equal 2, y equal 2, x equal 2, y equal 3. And so because those x values are always equal to 2, when we plot these points, they lie in a straight line, as they should. And this time we have what's called a vertical line. The line goes straight up and down a vertical line. And in fact, anytime you have an equation that's just x equal a number, you will always end up with a vertical line. Okay, so the example we did was x equal 2. We got a vertical line. If it was x equal 4, it would still be a vertical line. It would just be shifted over to the right. Turns out, if our equation is y equals a number, doesn't have any x's, if the y's are constant, we will actually always get a horizontal line. So on the screen, I have a graph of y equals 2. But the same would be true if you had y equals negative 1. You'd also get a horizontal line. It would just be moved down to negative 1. So these are two kind of special cases of lines. Our vertical lines only have x's in them. Horizontal lines only have y's in them. All right, so the second topic I want to cover in this video is the idea of intercepts. And an intercept is places where a line crosses the two axes. So I have a picture of a line in blue, and where this graph crosses the x-axis is called the x-intercept. In this case, that would be the point 2, 0. Where the graph crosses the y-axis is called the y-intercept. That's the point 0, negative 2. So one thing to notice with this image is the x-intercept is a place where y equals 0. And the y-intercept is a place where x equals 0. So if we want to find the intercepts of a line, for example, we have the line 3x minus 4y equals 12, we can plug in 0 for x. That'll give us the y-intercept. And then we can plug in 0 for y, and that'll give us the x-intercept. So plugging zeros in for x and y will give us those intercepts. So I'm going to start by plugging in 0 for x. 3 times 0 minus 4y equals 12. That's minus 4y equals 12. Divide by minus 4, so y is negative 3. We solve for y, so this is our y-intercept. Our y-intercept is the point 0, negative 3. To find the x-intercept, I plug in 0 for y. So now I've got 3x minus 0 equals 12. So 3x is 12, divide by 3, x is 4. We solve for x, so that's our x-intercept. Finally, when we write intercepts, we frequently list them as ordered pairs. So the x-intercept, we solve for x, that would be the point 4, 0. We plug 0 in for y. The y-intercept was 0, negative 3, so we'll write that as the ordered pair 0, negative 3. All right, let's do one more. Find the intercepts of the line y equals 1/2 x plus 6. So exact same process. We're going to plug in 0 for x, and then we're going to plug in 0 for y, and that'll give us both of our intercepts. So if I put 0 in for x, y equals 1/2 times 0 plus 3. Well, 1/2 times 0 is 0, so I just get y equals 3. My y-intercept is at 3. To find my x-intercept, I'm going to plug 0 in for y and solve for x. So 0 equals 1/2 x plus 3. I'm going to minus the 3 to get the x by itself. So now I've got minus 3 equals 1/2 x. And I want to get rid of that fraction 1/2. So to do that, I'm going to multiply both sides by 2. 2 is my denominator, and so let's clear the fraction by multiplying both sides by 2. 2 times negative 3 is negative 6. 2 times 1/2, half of 2 is 1. So I'm left with 1x equals negative 6, and that is my x-intercept. So finally, as ordered pairs, the x-intercept is negative 6, 0, and the y-intercept is 0, 3. All right, that was my last example in this video. Please let me know if anything is unclear.